dot point. All right, that's half of the lesson. The other half, forget I only have so much time. I better hurry here. The other half is to talk about even and odd functions, describing functions as even or odd. Of course, I forgot to hit the stopwatch, so we'll see here. So if I have an even function, there's a couple things that we know. We know that when I input an opposite of x, I should get the same as f of x. Well, that's the technical speak for that. Let's take a look at points and see what this means. This means that if I have a point xy, and 1, 2 is one of the points, okay? I know right away that if I put in -1, that 2 is also a point. If I have -3 and that's at 5, then +3 is also at 5. If this is an even function, this must happen. If I have 0, 8, okay, how do I make this x's opposite? You don't. 0 is 0, you don't get an opposite for that. So it's still at 0, 8. And if I have 3 and this is 20, then of course -3 is at 20. I don't know if I did this justice, but what's going to be happening then, when I sketch this, over 1 up 2 is a dot, left 1 up 2 is a dot. Left 3 up 5 is a dot, right 3 up 5 is a dot. 0 is up at 8, okay? And over at, 3, guys, wait, that's not a function, right? How about we do that? 4s, right? We can't have the same x values in two different, we can't have that. So we're going to take a look at this. We're going to say at 4 it's at 20, -4 it's at 20, which means it's going to go up here, which means I might have something that's doing this, going up there really fast. And what do you notice about the graph? We have some symmetry. So sometimes when you say, oh, graphically, this is symmetry over the y-axis, so it's reflected over left and right, that's what we see on graphs of even functions. Now, remember, just because you see somebody and they're smiling and it looks like they're having a great day, but you might go up to them and say, hey, how's it going? And you expect this great positive answer always. They might go, oh, yeah, it's, they might just calm right down. And so, same thing, you walk up to somebody and they're just kind of going, You say, hey, how's it going? Oh, great, it's awesome. And they might have been just thinking about something. So you can't really tell. When you look at a graph, you can't tell for sure that it's even or odd just based on looking at the graph. You get a hint, you get an idea, but sometimes you're wrong. So don't get snap judgment. What we need to do is we need to figure out if it is or not. And to do that, we have to use that definition. So if I say, here's my function g of x, and let's do a really simple one, x squared plus 4. Okay, or let's go minus 4. All right, here's how I'm going to prove that it's even. How do I prove that? I better do some colors here. We'll go to g and we'll put the opposite of x into there. And we'll see what we get. So we put the opposite of x into this idea that whatever I get, I'm going to square it, the input, and then I'll subtract 4. Boy, I hope we can still see that. So we square it, we subtract 4. The opposite of x is like -1 times x. -1 times x times -1 times x is multiplication, and that's squaring it. You're multiplying it by itself twice. Well, that's all being multiplied, so -1 times -1 by the commutative property is the positive 1. And x times x is x squared. And so by plugging that in, I come up with 1 times x squared. Now, we don't usually need to write the 1 there. We get x squared minus 4, and we see that that's what we started with. We put the opposite of x in, or -1 times x in. We did our algebra, and we ended up with this statement, which is exactly what we started with. So that equals g of x. By putting in the opposite of x, I get g of x. Therefore, ... g of x is even. All right? Now let's try this on one where I don't see any graphs. Oh, by the way, that's for even. An odd function, you can do the same thing. I'll let you do the reading on that so we don't take up time. But odd would be if the f of the opposite of x. Again, you start by putting in -1 times x into the function. If you just get the exact opposite, switch the sign and everything, then that will be odd. If neither of those happen, then the function is considered neither odd nor even. Okay? All right, here's the last one where I picked a great one out here. At least I thought I had a great one for you guys. Oh yeah, that's all I was going to do. Okay, so let's say that h of x equals 3x squared minus 4x plus 2. And you notice, okay, well there's an odd number in here, there's even numbers, there's subtraction, there's addition. This could be, well, wait a second. Maybe what we want to do is we want to make all of these be even numbers. Yes, we do. We want to make this be an even number. How about we make this 6? 6x squared minus 4x plus 2. Look at those. They're all even numbers. This must be an even function. Let's figure it out. How do we prove, this is going about proving it analytically, not just guessing by looking at it, not just by checking a few points, but how do we prove that this is even, odd, or neither, is we ask it, hey, what is the value of h at the opposite of x? All right? So we're going to put into this h of x, we're going to put negative 1 times x. Well, that will be 6 times the opposite of x squared minus 4 times the opposite of x plus 2. All right? So I've just put in the negative 1 times x. Now I'm going to take and do my orders of operations, which is to square this. Okay? So this will turn out to be 6. The opposite of x squared is negative 1 times negative 1 is positive 1. And that's x squared. Subtracting 4 times negative x is subtracting a negative 4x plus 2. Well, I was always taught that subtracting the opposite, okay, subtracting a negative, is adding a positive right there. So that's addition. And then we take a look. That is what the value of the function h at the opposite of x is. It's right there. Let's compare that to h of x. H of x is 6x squared minus 4x plus 2. Are those two things term for term the same? No. So we make a claim. Because when I put in this opposite of x, I did not get the beginning. We say, therefore, h of x is not even. Okay? Well, now we want to check for odd. All right? So what is the opposite of h of x? I need to compare. If I compare h of x to this result, that tells me if it's even. If I compare it with the opposite, well, how do I get the opposite of h of x? You take the opposite of each of the terms. Okay? And again, there's two negatives there, right? So that's subtracting a negative. It's really adding a positive. And now I compare this. Are those two the same? No. Are those two the same? Yes. Are these two the same? No. So when I found the opposite of each of them, it didn't match this either. In both cases, I'm looking for this statement here, either the original to match what I got for h of opposite of x, or the opposite of h of x to match that answer. Because that did not match, we say, therefore, h of x is not an odd function. And what does that leave me with? So, h of x is neither odd nor even. Okay? Your job is to complete the day 2 assignment. Hopefully I haven't taken too much time. Good luck. Go ahead and look at other videos if you want. Khan Academy. I'm sure you can find this on the Larson website, the free Larson website that's on the link. And hopefully that explains that. And